next we're going to work on finding the volume of cones. And it's going to be very familiar to you. It is almost exactly like finding the volume of pyramids, okay, except for one difference. The base of a cone is different than the base of a pyramid, okay? So just keep that in mind. Let's look at your real-world link here. It says, Grace and Elle are making snow cones for the school carnival. They want to know how much ice goes into a paper cone that has a radius of 1.5 inches and a height of 4 inches. So number one, it says, recall the formula for finding the volume of a rectangular pyramid is V equals 1/3 base times height. Okay, that's the formula that we use for a rectangular pyramid. How does the volume of a pyramid compare to the volume of a prism with the same base and height? Okay, so we're comparing a pyramid to a prism. Well, we learned last time that the volume of the pyramid is 1/3 the size of the prism. Okay, so what do you think the volume formula is for a cylinder? Well, you know what that one is. Okay, it's pi r squared times h. So what they want you to do next is, what is the volume of a cylinder that has a radius of 1.5 and a height of 4? So what they're asking you to do here is they're kind of comparing it to the cone. These are the same dimensions as the cone, okay, but except it's a cylinder. So right now, go ahead and pause the video and find the volume of the cylinder, okay, and then we'll compare it to the volume of the cone. Alright, so the volume of the cylinder, okay, that has the same dimensions as the cone that they're going to use at the carnival, okay, is 28.26 inches cubed. Okay, then it says the volume of the cones that Grace and Elle are using is about 9.42. So here's the cylinder and here's the cone. Okay, what they want you to do is take this and write a ratio in simplest form, comparing to the volume of the cone, so 9.42 on top, to the volume of the cylinder, so 28.26, and then reduce it. And what you'll find is it's 1/3. So it's the same thing as the pyramid and the prism. A pyramid is 1/3 the size of a prism. A cone is 1/3 the size of a cylinder. Okay, so here's your formula for finding the volume of a cone. Let's look at it more specifically. Okay, here's your cone. Okay, it has a radius because the base is a circle, and it has a height. And again, just like the pyramid, the height is dropping from the center right down through the middle of the cone, down to the center of the circle there. So you can see here's our generic formula right here. Okay, V equals 1/3 base times height. And then this is a formula that's more specific. We took out that capital B and made it a pi r squared because our area, or our base, is a circle. So we had to replace the area of the base with pi r squared. Let's look at an example. So in this example, you have a cone that has a radius of 3 and a height of 6. So start with your generic formula up here. V equals capital B, that's a B, times h. Okay, then we take that b out and we plug in pi r squared. Okay, your radius is 3, so we square it, and your height is 6. Multiply it all out and you get 56.5. Okay? So what I want you to do right now, pause the video, go ahead and try these two cones, and we'll see how you did. Okay, for A, okay, we're going to start with your formula, your generic formula, 1/3 base times height. Now again, this 1/3 is because it's not a cylinder, it's 1/3 of a cylinder. Okay, so after that, let's get rid of your capital B and plug in the area of formula for this circle for your base, and that's going to be pi r squared. So we took the B out, plugged in pi r squared. Plug in what you know. Okay, you know that your radius is 2, your height is 7. Multiply it all out. You should have 29.3 feet cubed. Okay. Now over here, the difference between this one and this one is they give you the diameter, so you have to be careful there. There's your generic formula. There's your more specific formula for your circle. Okay, let's plug in. Your radius here is going to be 12, so be careful. 12 squared. Okay. Final answer should be approximately 3,918.7 millimeters cubed. Okay. Here's another example of finding the volume of a cone. A cone-shaped paper cup is filled with water. The height of the cup is 10 centimeters, so it's 10 centimeters tall, and the diameter is 8. What is the volume of the paper cup? Again, just fill in what you know. You know that your radius, if the diameter is 8, your radius is 4, your height is 10. Okay, multiply it all together, you get approximately 167.6. Okay. What you need to do, sometimes it helps if you draw a figure. So go ahead and sketch out a figure and then find the volume of the cone. Okay, the word problem says April is filling 6 identical cones for her piñata. Each cone has a radius of 1.5 inches and a height of 9 inches. What is the total volume of the cones? Round to the nearest tenth. Okay, so what I've done, I just went and made a really bad sketch of a cone here. My radius is 1.5, my height is 9. So I'm going to take my generic formula, take the capital B, the area of the base out, and make it more specific to a cone, which is pi r squared. My radius is 1.5, my height is 9. Okay, and for that I get 21.2. But it says up here that she's making 6 identical cones, and they ask you for the total volume. So what you're going to have to do is multiply this by 6. Oops, let's go down. And your total volume for all 6 together are 127.2. Okay? Let's look at a more complicated example. These, I think, are too easy for you guys. Volume of composite solids. Now again, we've talked about composites. Composites are two geometric solids put together. And all you have to do is just look at them separately, find the volume of each, and then add them together. So what you have here is you have a cylinder and you have a cone. So work on finding the volume of the cylinder first, which is what they do here. Okay, pi r squared h. They fill in what they know, and they get a volume for that cylinder of about 201.1. Then they work on the cone. So if you look over here, here's how they find the volume of the cone. 1/3 pi r squared. The radius is 4, so we 4 squared. The height of the cone is 5. So you get your total volume of the cone is 83.8. So what they do then is they add the volume of the cylinder, add the volume of the cone, and they get a total of 284.9 cubic feet. Okay? Try the got it problem. Now in this problem, they have 2 cones stuck together. So find the area of one cone, or find the volume of one cone, find the volume of the other, and then at the end you just add the 2 volumes together. So go ahead and pause the video and try this problem. Okay, let's start with a smaller cone first. Okay, there's our generic. There's our more specific. Okay, so in this cone right here, the radius is 6, so we have 6 squared. The height of the smaller cone is 5.5. So here we have 207.2 for the small one. Now your bigger cone, okay, there's our generic formula. There's our more specific. Put this up. And then we plug in what we know. The radius is still 6, that didn't change, but the height changed. Okay, and it's 13. So we get a total here of 489.8. So what we need to do then is we need to add these 2 for your composite figure. You need to add these 2 values together, and you should end up with around 697. Okay, you might have a decimal. It could be close depending on how you used pi. If you used the pi button or used 3.14. Okay, but you should get an answer somewhere around there. So you can see that a cone is very similar to finding the volume of a pyramid. Okay, it's still 1/3. And if you don't believe me, you can go back over to that station with the water and pour in, take your cylinder and add water with your cone and see how many times it takes to fill up, using your cone, how many times it takes to fill up that cylinder. And I bet it will be 3. Okay, so go ahead, try your guided practice problems, and we'll take a look at them in class.